Hi, my name is Matthew Webrink, and I'm here to present the V model of the comparisons between different project development processes. I found the V model to be pretty interesting in talking about it and whatnot. So, essentially, V model stands for verification and validation model. The verification's typically on this side, whereas validation is more focused on this side of the V. And it's similar to the waterfall model in that it's like very well structured and kind of linear in the sense of there's a certain process of how you go about doing things. So the right side over here coincides with the left side, but you have to do the left side first, and then this stuff kind of, in a way, sorts itself out in a sense as you develop your product. And the big key characteristic is that the testing, everything's planned in parallel in a complementary phase. So you'll have your concept that you want to do, and then you'll plan a system validation plan of acceptance test for the system validation stage, for like the big broad scope of the project. And then as you go down to each subsystem, you'll do more things relating to each of those specifically. Some advantages to the V model. It's a lot like waterfall, so there's an advantage there in the sense of that there's a lot of structure to it, and you have to kind of go in an order of things. So if you're working on it or working on a project with it, then you generally know where you're at and where you're going and whatnot. Has better time management as well because of these validation and verification points that happen along the way. You save time because you do a whole lot up front, but it ends up saving time later on because of all the acceptance tests. So you know that by the time you get to this right side of the V, that everything really should be working according to plan because you've already been testing it. And because of all the early testing, then you have minimal risk and prevention of critical errors. Some disadvantages to the V model. It's impossible to adapt the model to continuous changes. So a good example of that would be if you're going along the way here and then all of a sudden your client says, oh hey, we want to switch it up entirely or change everything. Well, you've already committed a whole lot of resources to this broad system scope and planning everything to it, and depending on how far you've gotten along the way to all the different subsystems, it can cause issues. So typically how changes happen is you go all the way through the process, and then after it's been released, you can do changes and upgrades in the form of a retirement or total replacement of the product. So you can build off of it, but by that point, it's kind of like it's its own thing because of how far along the process it went. There's usually no actions devoted to risk analysis, and specifically that's more of different levels of subsystems in the hierarchy speaking to each other. You don't really test for that sort of risk of bugs. So typically everything like on these levels should be working according to plan, but you don't know if there's an error in between on interactionality of these subsystems that are based off of each other. And then the development is time consuming, so one of the biggest disadvantages to the V model is if a project goes on for so long, then sometimes it just might grow out of necessity or its core audience. Basically ends up being like, why was that needed anyways, sort of thing. So where we might see the V model, it's actually kind of interesting. The German government, it's their official project management method for their federal administration, defense, and software projects, of course sponsored by the state. So found that to be pretty interesting. It kind of goes along with a lot of like German manufacturing philosophy as well. So the similarities there made sense. Small to medium-sized projects where the requirements are clearly defined and fixed. So this would probably be more like on a university setting, I would assume, and like smaller projects in business, just because you're not going to be spending a whole lot of time with it, but you can do the acceptance test and whatnot on these projects pretty quickly and whatnot. Where a technical expert is in need with abundant technical resources. A good example of this actually is going to be something like SpaceX, where you have quite a bit of money and you are basically just doing a project that like no one knew they wanted, but it was like a great innovation, such as the self-landing rockets. And then medical software and flight management software, because it's software that needs to be free of critical errors and have no downtime, such as MRI machines and CT scanners, as you can see below here. Thank you very much.